Metals are amongst our most valuable resources. Thousands of years ago, people used metals such as copper and iron to make weapons and everyday objects. These metals are still in use today. Can you identify objects around a house or compound that are made of metal? Click on the object if you think it is made of metal. Most of these metals exist on Earth as metal ores such as metal oxides and metal sulfides. Do you know how the metal extraction industry contributes to the economy of our country? At the end of this lesson, students should be able to describe the various applications of the change of oxidation number in substances. Describe the existence of various types of ores in our country. Describe efforts to prevent corrosion of metals. Describe the contribution of metal extraction industry to the economy of our country. Appreciate the chemical cell as a source of renewable energy. Redox reactions involves change of oxidation number in the reactants. Redox reactions have many far-reaching applications in our lives. These are a few examples of the applications. Click each of the blue boxes to know more. Imagine life today without the voltaic cells. There'll be no cars, no mobile phones, no torches, no Walkmans, no laptops, in fact, no portable electrical appliances at all. Let us look at some of these cells that generate electricity. Click the blue button to see how these cells work. Zinc carbon dry cell is the simplest and cheapest cell in the market that we can get. The container of the zinc carbon dry cell is a zinc can containing ammonium chloride with zinc chloride aqueous paste acting as the electrolyte. The carbon rod containing a mixture of powdered carbon and manganese 4 oxide or MnO2 is separated from the aqueous paste by a paper layer. The manganese dioxide is mixed with carbon powder to increase its conductivity. The outer zinc container is the anode. Here, the zinc is oxidized. The electrons travel along the external circuit to the cathode. In this half reaction, the zinc is oxidized from an oxidation state of 0 to +2. A carbon rod is the cathode. At the cathode, the hydrogen ions accept the electrons and combine with oxygen from manganese dioxide to form water. The cathode reaction is as follows. The hydrogen ions come from the ammonium ion in the electrolyte. In this half reaction, the manganese is reduced from an oxidation state of +4 to +3. There are other possible side reactions, but the net reaction in a zinc carbon dry cell can be represented as follows. The voltaic cell has an electrical potential difference of about 1.5 volts. Accumulators are most familiar to us as large, powerful car batteries. A lead-acid accumulator contains 3 or 6 separate cells inside a tough plastic casing. Each cell contains lead and lead-4 oxide electrodes with dilute sulfuric acid as the electrolyte. When the battery is supplying current, each lead atom loses 2 electrons and is itself oxidized to lead-2 ion at the negative terminal. The lead-2 ion then combines with the sulfate ion to form an insoluble lead-2 sulfate. Thus, lead underwent a change in the oxidation number from 0 to +2, whereas at the positive terminal, each lead-4 oxide molecule received 2 electrons in the presence of 4 hydrogen ions and is itself reduced to lead-2 ion and 2 molecules of water. The lead-2 ion then combines with the sulfate ion to form an insoluble lead-2 sulfate. Thus, lead underwent a change in the oxidation number from +4 to +2. The overall reaction can be represented as such. The sulfuric acid electrolyte is gradually used up to form the insoluble lead sulfate. When it is completely used up, the battery can no longer supply current. It is flat. It can, however, be recharged. When the car engine is running, or when the battery is connected to a charger, electric current is passed through the battery. This reverses the sign of the terminals and reverses the process at the terminals too. The battery is again able to supply electric current. A fuel cell is a device that converts chemical energy of a fuel and air or oxygen into electricity. The fuel could be hydrogen, natural gas, gasoline, or any other fuel. There are different types of fuel cells. One of them is hydrogen fuel cells. How does a hydrogen fuel cell work? Hydrogen gas is channeled to the anode. Oxygen gas is channeled to the cathode on the opposite side of the cell. The platinum catalyst at the anode causes the hydrogen to split into hydrogen ions and electrons. Hydrogen undergoes changes in its oxidation number from 0 to +1. The special electrolyte allows the hydrogen ions to pass through to the cathode. The electrons travel along the external circuit to the cathode. At the cathode, the hydrogen ions accept the electrons and combine with oxygen to form water. Oxygen undergoes changes in its oxidation number from 0 to -2. The produced water flows out of the cell. We have seen 3 types of voltaic cells that can generate electricity. Can these voltaic cells be a source of renewable energy? Choose one type of voltaic cell that you think is a source of renewable energy. State the reasons why the voltaic cell that you chose is a source of renewable energy. Discuss in groups of 5 and present your point of view to the class. Millions of ringgit are lost each year because of corrosion. Much of this loss is due to the corrosion of iron and steel, although many other metals may corrode as well. Unfortunately, it is a soft, crumbly substance that soon flakes off. This will then expose the remaining iron metal to further corrosion. When iron corrodes, it undergoes changes in its oxidation number from 0 to +2 or +3. Our efforts in preventing corrosion is by coating the iron or steel with paint, grease or oil, plastic, a less reactive metal, or a more reactive metal. Malaysia is endowed with a variety of mineral resources. The major metallic ores are tin, bauxite, and iron. Our country rarely exports metallic ores nowadays. Let's see how some of these metals are being extracted. In the extraction of iron from iron oxide is reduced by coke to iron and carbon dioxide. During the reaction, iron undergoes a change in oxidation number from +3 to 0. On the other hand, aluminium is extracted from aluminium oxide through electrolysis. The electrolysis is done in cells, as can be seen in the animation. During electrolysis, aluminium undergoes a change in oxidation number from +3 to 0. How does the metal extraction industry contribute to the economy of our country? The extracted metals are used to manufacture high value-added products like machinery and appliances. In the year 2006, our country exported 300 million ringgit worth of electronic and electrical products. Indirectly, the mining industry has contributed significantly to the country's economy. Not only do we produce high value-added metal products, but we also make aluminium and steel cans. Where do we throw them after use? Should we burn them in waste-to-energy plants? Should we landfill it, or should we recycle it? If we keep on extracting metals from their ores, soon they will be depleted. It is important to recycle the metal wastes so that we do not have to extract more metals which would one day be depleted. Furthermore, it takes less energy to recycle the metals than it does to mine them. For example, in the recycling of aluminium, 95% of energy is saved compared to extracting it from bauxite. Besides reducing pollution and global warming, we also have other benefits such as preserving the metal ore supplies and less scars on the landscape made by open-cast mining. Click the blue box to see how aluminium is recycled. The metal scraps are taken to an aluminium reclamation plant. The scraps are shredded into small pieces and fed into a melting furnace. The molten aluminium is gradually hardened into rectangular slabs called ingots, and then formed into thin sheets of aluminium. Aluminium and steel can be recycled again and again without losing their strength or quality.